Hello, Wayland Middle School. Mr. Farley here for a quick video on graphing linear inequalities. It's pretty cool. This should be good, and let's check it out. Hopefully this will go well. So you will be given an inequality. Fortunately for us, it's in a really good form. It's looking almost like slope-intercept form, y equals mx plus b. But it's not an equation, it's an inequality here. But we would start graphing this the same way. We look for the y-intercept, which is a positive 3. Go to put that point right here. I then look at the slope. Slope is 2. Just a reminder, slope of 2 really means 2 over 1. So I can rise 2 and I can run 1. And that would give me another point. I'm going to do that backwards. So instead of rising, I'm going to fall 2 and go left 1. Going to do that a couple of times too, so I can really see what this inequality, the boundary is here. So there you have it. Looks like this. So typically, if this was an equation, we would just go draw the line through it and be done with it. But inequalities are a little bit different. So what we have to do is first identify the inequality symbol. It is a less than because it is not or equal to, okay? Because it's just a less than. We are going to take these points and we're going to connect them with a dashed line or dotted line, all right? So this is the first thing to think about. We have dashed lines because the inequality symbol is less than. If it was a greater than, we are going to have also a dash line. So if it's less than or if it's greater than, it means it is a dashed line. Okay, it's a dash line. Okay, so just to say again, if it's less than, it will be a dash line. If it's greater than, it will be a dash line as well. So here we have it. This is what it looks like right now. But now we have to test a point to see if there are other solutions that will work for this. So I like to always test the origin. That's what I like to do. I start at the origin, and I know the coordinates of the origin are 0, comma 0. So what I do is I plug in 0 for x and 0 for y into this statement to see if it's true. So if I do that, y is 0. Is that going to be less than 2 times 0, which is 0, plus 3? Well, yes, 0 is less than 3. Because of that, that tells us that the point 0, 0 right here is also a solution to this inequality. But there are actually an infinite number of solutions to this, and all of them are in the region that the origin is part of. The origin is located below and to the right of the dashed line. So this region that I am shading in right here would contain points that are solutions to this inequality statement. So you would also see if you tested a point out here on the above the line or to the left of this dashed line, a point out here would not work in the original statement, which means it is not a solution. So all of the points in this shaded region, okay, these are the solutions to this inequality. All right, so that's the first one. Second one, let's take a look at this. It's a pretty good one too, by the way. You'll like this. So it's a little bit different, same idea. I have an inequality statement with a greater than or equal to. So right now that should start ringing some bells, because if we have a less than or equal to or a greater than or equal to, oops, I don't know why I did that, greater than or equal to, we will not have dashed lines. We will have a solid line. I'll write it like this. Yay, look at that. A solid line. So when I look here, y equals mx plus b, y-intercept -4. Slope is 2/3 up 2 over 3. Going to do that a few times. Up 2 over 3. I'm kind of off the graph a little bit, but that's all right. I'll go down 2 and left 3. That's over here someplace. So that gives you an idea of where the boundary is for this. Now, because it's an or equals 2, what I definitely need to do here is put a solid line connecting those points. I did my best there. It's not the best line you've ever seen, but it's decent. So there you go. That is what it looks like if this was going to be an equation, but this is an inequality. So just like the last example, I like to test the origin. Okay, the origin is easy to test. It's 0, 0. I am going to plug in the points 0, 0, or plug in these coordinates to see if it works. Let's try it. Y is 0, so y is 0. X is 0. 2/3 times 0 is 0, minus 4. And now I test it with the inequality. Is 0 greater than or equal to -4? Well, yes, it is. It works. That means the origin is located in the region where there will be solutions to this inequality. So not only do we graph the line here, but we also shade in with your pencil the region above and to the left of that line. So all of this gets shaded in, all right, because points in this region here are all solutions to this inequality. If you tested a point on the other side, you would realize, well, the points over here would not satisfy this inequality and therefore are not solutions. So hopefully that makes a little sense. If you have some questions, let Mr. Robinette or me know, and we'll definitely check in with you. These can be a little tricky, a little tough to get used to, but once you get going, they work out pretty nicely. So again, any questions, let us know. Hope you enjoyed this award-winning video. Take care.